Okay, this is the 3-2 lesson. And we are going to get into triangle congruence. And we're going to talk about 3 specific ways to prove triangles congruent. But first we have to talk about some key theorems and postulates. And all of these are review, but you want to have them active in your brain. If you haven't learned them from studying your flashcards, you're probably going to want to really buckle down and work on those right now. The reflexive property is one we learned earlier, and I introduced it as A equals A. And you thought it was kind of a silly property at the time. But where it's going to come into play now is in triangles like this. Triangle A, B, C, D. And if you look closely at this triangle, there are 2 triangles here. And we're going to try to prove that this green one is congruent to this red one. If you look closely, they share this common side right here. So one of the steps we're going to have to write is that AD is congruent to AD. Another way that you will see this is what I call twist proofs. I drew that backwards. Sorry, drew that backwards. And you're going to see twist proofs like that. And what happens here is here we have the red triangle that we are going to try to prove congruent to the blue triangle. And they also share this side, except when I line up my vertices, you can see it's twisted, that GJ is actually congruent to JG. One thing that helps with the reflexive in some of these triangles is if you separate your triangles out, sometimes you can see that indeed this angle is going to match up with this angle and that angle with that angle. And that's why we have to do the congruence statement in a twisted way. More on that later. Parallel lines on their angles and their parallel lines from last unit, super important. Isosceles triangle theorem from the 3-1 lesson that says if I have the sides equal, I get the base angles. If I have the base angles, I get the sides equal. Substitution is always going to be one of our favorites, adding and subtracting. Our supplementary and complementary rules. A few additional properties that are review are ideas of medians, that they bisect, that they are the midpoint of that side. Perpendicular bisector from last unit. An angle bisector is an important idea. The midpoint theorem, and probably one of my personal favorites is the vertical angle theorem. There are only a couple of things we can assume from a picture in a proof. The reflexive property is one, the vertical angle theorem is one, and linear pairs is one. Everything else you can't assume because, as we say in class, pictures lie. So what is this triangle congruence? It's a way, without proving all 6 parts, to say that triangles are congruent. It's a shortcut. So first shortcut is angle-angle-side congruence. This says if I have 2 angles and the non-included side, and that's the key, the non-included side, which would be this side and this side, or I could also include this side and this side. Okay, so 2 angles and either one of those sides, and I can conclude my triangles are congruent by angle-angle side. And just for practice, our congruent statement would be CBA. Go ahead, do the first one in whatever order you want, then take your time matching up the second one. C has 2 hash marks, so does D. B has 1 hash mark, so does Y. A has none, and there is X. Side, side, side is exactly what it sounds like. If all 3 sides of one triangle are congruent to all 3 corresponding, and the corresponding is a key word in all of these theorems, you can conclude that they are congruent by side, side, side. So here I have my hash marks, which tell me that my sides correspond. So if I do triangle AHT, that would be congruent. A is by the 1 and 2 hash marks. S is also by the 1 and 2 hash marks. H is by the 1 and 3 hash marks. R is by the 1 and 3 hash marks. And that leaves T and I to pair up. Now, since we know these by side, 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 the three things I knew were the sides. By CP-CTC, those corresponding parts of congruent triangles, I get that angle A is congruent to angle S, angle H is congruent to angle R, and angle T is congruent to angle I. Let's go back a second and just quick look at that. If I know that these guys are congruent by angle, side, as given in the picture, by CP, CTC, corresponding parts of congruent triangles, I get the remaining angle, angle A, is congruent to angle X, and the two remaining sides, that CB is congruent, get the order right, to ZY, and that CA is congruent to ZX. That's how CP-CTC works. And now our last theorem for the day is angle side angle. The side in the name is between the angles, and so if you think about it, we have two angles and the included side, the side between the two angles. So the names really should help you know where things are. I know this angle, this side, this angle, the side between, and that angle. So these two triangles would be congruent. Triangle DCE is congruent to triangle ORN by angle side angle. By CP-CTC, in this case, I get the other angle. Angle D is congruent to angle O, and I get the other two sides. DC is congruent to OR, and DE is congruent to ON. Now to take a look at some examples. First part, A, give the congruent statement and the reason these triangles are congruent. I see hash marks on all of these sides, and so I know that triangle ACB is congruent to triangle. A is between the 1 and the 3, R is between the 1 and the 3 hash, C is between the 2 and the 3, T, B is between the 1 and the 2, and I. ACB is congruent to RIT by side, side, side. Then by CP, CTC, that's part A. Part B, I get all three angles, which is angle R is congruent to angle A, which is equal to, we don't know yet. Let's look at our other ones. Angle I is congruent to angle B, which is equal to, here's B, here's I. Congruent means they're identical, 66. And angle T is congruent to angle C. Here's C, here's T, 39 degrees. When you add 66 and 39 and you subtract it from 180, that means that R and A have to be 75 degrees. This example is hopefully to help you see the difference between angle side angle and angle angle side. I'm going to cheat a little bit here, and I'm going to copy this and see if I can paste it and make it a little smaller so that we can look at multiple examples of this angle side angle, angle side property. That ought to work perfectly. All right, so congruent by angle side angle. If I know this angle and this one, Angle side angle is the included angle. I need this one. So I need to know that CB is congruent to FE. Now, angle side has two options. The non-included side, I could do this side and this side. I could do that AB is congruent to DE, or I could do that CA is congruent to FD. And both of those would give me the triangles congruent by angle, angle, side. The congruence statement, regardless of how we prove it, is triangle ABC is congruent to triangle A matches up with D, B matches up with E, and C matches up with F. Are these triangles congruent? This is a catch place that kids have trouble. If you notice, my angles match up nicely. All is good. There's an angle, there's an angle. The problem is where is the side? Here it's adjacent to the 2 hash angle. Here it is adjacent to the 1 hash angle. So these are not congruent because the sides are not corresponding. I could not line these up and make them match. I'm going to continue